So give me 2 little seconds. If you all could, just so that I know who's here, just log in to thescienceroom.org and then go to the review, thescienceroom.org/review. That would be very helpful for me just to know how many people are here. And welcome. You made it to the right place. All right. So what I'm going to do is actually start using this PowerPoint. So if you wanted to follow along with the PowerPoint, you can, or you can follow along with just looking at the screen. If the screen is just way too difficult for you to see, let me know. That's the only way I can tell. All right. All right, so we're looking at Earth Science SOL Review. And again, this is available through Google Docs. And if it is not, please let me know, because this is something that should be available to everyone. All right, oceanography. So we talked a little bit about oceanography towards the end of the quarter, but we haven't talked about it a whole lot. So we have some good time, a little bit of time right now to talk about it. So oceanography, the main thing that we learned was how water moves around the Earth. So we have level caused by the moon's gravitational pull. We also know that the sun causes the tides as well, but because the sun is so far away, it definitely has less of an effect than the moon does. Okay, ocean water level caused by moon's gravitational pull causes 2 high tides and 2 low tides every day. So we have the different types of tides depending on where the sun and the moon is. So we have spring tides. Here the greatest tidal range happens. We have the highest high tides and we have the lowest low tides. And this is because this happens when the sun, the moon, and the earth are all in alignment. We also have neap tides. Neap tides are the lowest tidal range. So in this case, we have the high tides are lower and the low tides are higher. Okay. One of the ways that we remembered this is we said spring, string, strong. So when the sun, moon, and earth are all in a line, then we know that we have a spring tide, and that can happen during a full moon or it can happen during a new moon. The neap tides happen during the first quarter and the third quarter. Okay. More oceanography. So we also looked at waves, and we learned that waves are generated by the wind. The ocean is the largest reservoir of heat, and therefore it drives most of Earth's weather systems. One very important part of oceanography was learning that water takes a long time to heat up and a long time to cool down. So what that will do is that can cause, anytime you live near the ocean, your winters will be slightly warmer and your summers will be slightly colder. Okay, so it regulates. We say that it regulates temperature. Then also take a look at this map here. Current systems are created by the Coriolis effect. We know that the Coriolis effect is caused by the spinning of the Earth and wind. In the northern hemisphere, currents turn clockwise and warm water moves towards the poles, and cold water moves towards the equator. And this is convection currents. Now, convection currents should sound familiar because we also talked about convection currents that happen in the mantle. And the convection currents that happen in the mantle are what move the plates during plate tectonics. So sea level can also change. Sea level rises, when polar ice caps melt, and sea level goes down when more ice is created. All right, so just take a look at this map briefly. And what you will hopefully notice is right here where it says the Gulf Stream, we have this is the convection, this is the Gulf Stream that comes up. It brings warm water from way down here, brings it up the coast. So in Virginia, our atmosphere, our climate is artificially warmed by this Gulf Stream. All right, we talked about upwelling. Upwelling occurs when cold water sinks. We know that cold water is more dense, so cold water will sink, and it forces the water on the bottom to be pushed up to the surface. And this results in cold bottom water rising up to fill this gap. This water rising will bring completely different nutrients up to the surface. So the nutrient-rich water provides extreme amounts of food for fish, and therefore upwelling areas are known for rich biological activity. That's the main thing you need to remember about upwelling, is that it brings up nutrients, so a ton of fish come in and just feed off this area. Looking at this map on the right, this is a map of our beautiful Chesapeake Bay. Chesapeake Bay is an estuary. An estuary is where freshwater rivers meet saltwater areas. The Chesapeake Bay is an example of this. There are variations in salinity, which is salt content, and diverse biological activity. All right, we also talked about salinity, element concentrations, and density currents. So salinity is the amount of salt in the water. The average salinity is 3.5%. Because water is denser than fresh water. So some of you have noticed that when you go to the beach, it's a lot easier to swim and to float than it is at a pool. And that is because ocean water is more dense than fresh water. Okay, that salt increases the density, so it makes it easier to float. And if you take a look at this picture, lower left-hand corner, you can see that cold water will sink, and it will sink all the way to the ocean floor and slide down under the warmer water. All right, concentration of elements in the ocean. The ocean contains about 70 different elements, and these are the top 3. So sodium and chloride, obviously. Sodium chloride makes salt. So the chloride comes from volcanoes. We get a lot of good stuff on Earth from volcanoes. And 31% is from sodium. So the sodium, we talked about how water, as it's washing down from the tops of the mountains, it dissolves parts of the rock and brings that into the ocean. And then we have our sodium, 4% magnesium. Density currents occur when dense seawater moves to a less dense area. Cold water moves to warm areas. Water with salt is more dense, and evaporation or the formation of ice may cause the salinity of water to increase. So evaporation will cause salinity to increase because water will evaporate, but it leaves the salt behind. So now you have a higher percentage of salt than water. And also when water freezes, the salt doesn't freeze, just the water does. So whatever water is left unfrozen will have a higher salinity. Melting ice caps is obviously the opposite. So melting ice caps will cause the salinity to decrease. Species types in the ocean and oceanic landforms. So we did not talk very much about species. Pelagic species live in the seawater, and then benthic species live on the bottom. And that's pretty, but benthic bottom. That's fairly easy to remember. Now look at these features of the ocean floor. This should be familiar. So we have the abyssal plain, continental slope, and the continental shelf. A seamount is just an underwater volcano. A guyot is like an underwater volcano that gets eroded because sea level drops and then may rise back up again. The ocean ridge with the rift valley, we should know that this is formed by a divergent plate boundary. An example is the mid-ocean ridge. And we have trenches. Trenches are formed at convergent plate boundaries. So trenches are the deepest parts of the entire ocean. And abyssal plains are the flattest areas on Earth. Sediments fill any crevice immediately. Seamounts are underwater volcanoes. Continental slopes have canyons and extreme movement of sediment. And we have something called an atoll, and these form around extinct volcanoes. Extinct means that they cannot erupt again. It's different from dormant. Dormant means sleeping, similar to the word dormir, so sleeping, as opposed to not happening again. And around the atolls, you can see lots of coral structure. All right, we're going to move into the atmosphere. Earth's atmosphere is 21% oxygen and 21% oxygen and 78% nitrogen. Human activities, cars, factories, burning land, and coal have increased carbon dioxide levels, causing a slight greenhouse effect. And again, the greenhouse effect is not bad. What we're concerned about is that it's increasing very, very quickly. Water vapor and carbon dioxide help the earth retain heat and make it warmer. Burning fossil fuels also causes smog and contributes to acid rain. Venus has an extreme greenhouse effect due to carbon dioxide. Energy transfer in the atmosphere involves convection, radiation, and conduction. So let's take a look at this top picture here. We are able to remember the layers of the atmosphere by the saying, tropical storms may threaten everyone. And in this picture, we don't have the exosphere, but sometimes you will. So the tropical is the troposphere, storms is the stratosphere, may is the mesosphere, threaten is the thermosphere, and everyone is the exosphere. We live in the troposphere. In the troposphere is where almost all weather occurs and almost all airplanes are in. Right now, I don't believe we have any, at least not any commercial airlines that will fly into the stratosphere. In the troposphere, what you notice is that as you increase in altitude, meaning as you go up, the weather gets colder and colder and colder. And this makes sense if you've ever seen a snow-capped mountain. The bottom sometimes can be quite warm, but if it's high enough into the atmosphere, you'll have snow at the top. But then when we hit the stratosphere, something different happens. The stratosphere contains something called the ozone layer. The ozone layer helps protect us from the sun's harmful UV rays. And it's almost like a sun sponge, and it will cause the temperature to do something different. Instead of decreasing with altitude, like the troposphere will, the temperature actually increases with altitude, and it gets hotter and hotter and hotter as you go up through the stratosphere. The mesosphere continues to get colder and colder again, and in fact, the mesosphere is the coldest layer of the atmosphere. And then you'll hit the mesopause, at which point the temperature will just continue to rise and rise and rise. This line that goes back and forth is called the thermocline. All right, let's look at this picture at the bottom. This is the greenhouse effect. With the greenhouse effect, what happens is the sun's heat comes in through the atmosphere. It reflects off of Earth's surface. And then instead of going back out into outer space, it actually bounces against the greenhouse gases and reflects back to Earth. We had the greenhouse effect long before there were humans, so it isn't as if we caused it in the first place, but we are causing the greenhouse effect to become very, very strong. And we're doing that by burning fossil fuels, because when you burn fossil fuels, you release carbon dioxide. And carbon dioxide is one of the greenhouse gases. The other two main greenhouse gases are water vapor and methane. So water vapor, methane, and carbon dioxide are the three most common greenhouse gases. And fossil fuels include coal, oil, and natural gas. And thanks to Ms. Griffin, we remember that the fossil fuels, you can remember it by solid, liquid, gas. Solid is coal, liquid is petroleum or oil, and gas is natural gas. Weather versus climate. All right, so weather describes the day-to-day, moment-to-moment changes in the conditions of the atmosphere. Climate describes weather patterns for a given location over a period of many years. Okay, so factors that can affect this long-term climate. Latitude. We remember that latitude are lines, imaginary lines on the globe that tell us how far north or south we are. Elevation tells you how high an area is, so altitude. Bodies of water. Cold ocean currents cause colder climates, and then warm ocean currents cause warmer climates. So if we remember back to a few slides ago, we learned that in Virginia, our climate is a little bit warmer than normal because of the Gulf Stream. The Gulf Stream brings up warm water from the south. And also position relative to mountains. Okay, if you live near mountains, your climate is going to be affected significantly. Okay, so weather is day-to-day, short-term changes. Climate is something that exists for a period of many, many years. All right, let's take a look at clouds. And if you're watching this today, it looks like we mostly just have cirrus clouds, which means that the weather is not going to be changing a whole lot. So it's going to stay beautiful for a while. So looking up here at the cirrus clouds, those are so high up that they are actually frozen. They look like little wisps of clouds up in the sky. I would also like you to know, and I'm not going to talk about all of these, I would like you to know cumulonimbus. Cumulonimbus is the big, huge storm cloud. And when you're down on Earth looking up, they appear to be so dark because they are very, very tall. And with them being that tall, it blocks out the sun. So it makes the clouds appear to be a much darker color. Cumulus clouds, however, are the nice, big, fluffy clouds. They're like the ones that you draw when you're a little kid and you're drawing your clouds for school. And then the last one I want you to know is stratus. Stratus are the low-lying clouds. Remember that strato or strata means layer. We talk about strata in historical geology when we're looking at like cross-cutting relationships, original horizontality, all of those guys. So those are like the layered clouds. All right, I'll just take a look at this diagram for a brief moment. All right, the four clouds I want you to remember are cirrus, cumulonimbus, cumulus, and stratus. In order for clouds to form, air must be at its dew point. A dew point is the temperature at which air is saturated. And water vapor condenses on small particles called condensation nuclei. And scientists can make clouds. They use something called silver iodide in times of drought, and they try to use the silver iodide as an artificial condensation nuclei. And they'll spray it into the atmosphere with the hope that they can form a cloud, which eventually can form rain. All right, wind. So we have this thing called the Coriolis effect. Earth rotation causes the deflection. Deflection means like bending of air in the atmosphere. So if you take a look at this picture, sea breeze circulation. This is something that happens because because water and land heat up and cool down at different rates. So sea breeze circulation, when the sun is out, the land heats up very, very quickly. So the land heats up the air rises. When air rises, it cools, condenses, and clouds form. So now you've got these clouds up at high in the sky. And the clouds, once you're up higher up into the sky, they're moving down over to the ocean. Okay, and then it will sink and move back into the land. And we call this a sea breeze. Sea breeze because we talk about wind from where the wind is coming from. So this is a sea breeze. At night, the opposite happens. By the time it's nighttime, the water has finally started to heat up a bit, and the land cools, heats up quick, and then cools down quickly. So at night, the air sinks over the land, causing high pressure, And that will be the high pressure air moves to areas of low pressure. So it'll move over to the water. The water is low pressure because that air is rising because it's warm. And you'll get an opposite feeling. You'll get the land breeze circulation. So a sea breeze happens during the day and a land breeze happens at night. All right, upper right-hand corner, let's take a look at these different winds. So because the Earth is rotating, the global wind patterns are broken up into these bands. We have in where we are, shortly farther south than where we are, we have something called the tropical easterlies. And again, the easterlies come from the east. Below the equator, we also have tropical easterlies. They're all coming from the east. Where we live, we have something called prevailing westerlies. And if you remember, all of our weather comes from the west. So when meteorologists are trying to predict our weather, they take a look at weather patterns that happen in the west, and that's how they're able to predict what's coming our way. Global wind patterns are caused by the unequal heating of Earth, creating convection currents. And we know that wind flows from high to low pressure. And in the United States, weather is controlled by these prevailing westerlies, which move from the west to the east. Okay. Tornadoes. A tornado is a violently rotating column of air that usually touches the ground. A rotating updraft of air is in a thunderstorm cloud may form a spinning column called a mesocyclone, which eventually can touch down to the ground as a tornado. Hurricanes. Hurricanes are the largest storms on Earth. It moves counterclockwise with the movement and winds that can reach up to more than 250 kilometers per hour. Hurricanes are areas of extreme low pressure that form over warm ocean water of at least 80 degrees. We have the intensity of hurricanes is measured on the Saffir-Simpson scale and is determined by sustained wind speeds. All right, so taking a look at this Saffir-Simpson scale, hurricanes are measured by wind speed. And these hurricanes are pretty massive. The ingredients required for a hurricane to continue are warmth, moisture, and rotation. And that rotation comes from the Coriolis effect, which comes from the rotation of Earth. Weather instruments. We have a sling psychrometer, which measures relative humidity. We have a barometer, which measures air pressure. We have a hygrometer, which measures relative humidity. And we have an anemometer and a wind vane. Anemometer measures wind speed, and a wind vane shows wind direction. So since we did not use these instruments in class, I just want you all to take a quick look at all of these pictures. Weather maps. So pressure is reported by inches of mercury or in millibars. Millibars are reported as 1012.3, but on station models it's done differently. So we did not talk about how these are going to be on station models, but you're not going to have all of those numbers on a station model because it would get pretty crowded, okay? Weather moves from west to east in the US, and symbols for cold fronts, warm fronts, pressure, and precipitation should be known. So if you take a look at this map, the blue lines with the little triangles, those represent cold fronts, and they move in the direction of the triangles. Warm fronts are represented by the little half circles, and they also move in the direction of the half circles. High pressure brings fair weather. Fair means nice. And it circulates clockwise, and the air sinks. Right? High pressure, the sinking air causes high pressure. Low pressure brings bad weather or rain, and it circulates counterclockwise, and the air rises. Air from high pressure always moves to areas of low pressure, which are gradients. Cold fronts. Cold air invades warm air, rain and thunderstorms. Warm fronts, warm air invades cold air, and this pretty much brings just like steady rain before it's completely passed. On a weather map, we have something called isotherms, which are lines of equal temperature. They're just like those contour lines that we talked about with a topographic map. And just like a topographic map, if the contour lines are the closest together, it means that it's the steepest slope. For isotherms and isobars, when they're the closest together, it means it's the most drastic change. So a drop in temperature or a drop in pressure. So isotherms connect areas of equal temperature. Isobars connect areas of equal pressure. All right, station models. So this is what I was talking about earlier with the pressure. The center circle, that tells you about cloud cover. So in this case, this shows it's overcast skies. And that's the type of cloud cover. So if it's clear, it's going to be a completely empty circle. A couple things that you do need to know. Wind direction and speed. This little flag that's coming off of that station model, it shows the direction the wind is coming from. So in this case, it is a northwesterly wind. It's confusing because it means that the wind is going towards the southeast. But we do not know if that wind will be changed at some point. It could be deflected. So we say where wind is coming from. We have, and I'm going to go around this counterclockwise. After wind direction, we look at speed, and you can use this little chart here to calculate speed. So here you have 2 long dashes and 1 half dash. And what that represents is the wind speed is about 26 to 31 miles per hour. Air temperature is measured in Celsius. And so here you have -2 degrees, which means it's 2 degrees below freezing. The present state of weather, you use your key for that, and it looks like it's snowing. The shaded portion indicates the amount of sky covered by clouds, so completely overcast. The dew point is again in Celsius, so here we see a -6 degree dew point. And I'm going to skip type of low clouds, and plus or minus sign indicates pressure higher or lower than 3 hours ago. So that plus sign or negative sign is really important because it shows what's happening to the pressure. Is the pressure dropping or is it rising? Remember, high pressure means clear skies. So if the pressure is rising, it may mean that the storm is passing. And it also shows the pressure change. So it has increased over the last 3 hours. And then the last one is sea level pressure in kilopascals. And here we have 965. All right, let's look at the diagram at the bottom. This is what a warm front looks like. They are red lines with little half circles. I think of them as like little suns, and suns are hot. So it's a warm front, and it moves in the direction of the circles. Cold front is always blue with little triangles. I think of the little triangles as like little icicles, and they move in the direction of the triangles. We also have an occluded front and a stationary front, which I'm not going to get into. All right.